Good day, everyone! How are you today? Are you all fine? So, I hope you are in a good health and a good state of mind. So, today I will going to present to you your new discussion. So, this will serve as your lecture. So, I hope you watch this, enjoy listening, and get some learnings. So, our topic for today is all about the angle of elevation and depression. So let's find out what is the angle of elevation and depression. For the introduction, so the angle of elevation and depression is used often in word problem. So it is used in mathematics. So especially those involving a person's line of sight as they look up at an object. So, these angles can be used to solve problems involving trigonometric functions such as the sine, cosine, and tangent, and the inverse trigonometric functions. So, first let us find out what is the angle of elevation. So, as you can see here, so the angle of elevation in real world scenario, the angle of elevation could be viewed as the angle you would look at compared to the ground around you when you look up into the sky to see a bird flying. So as you can see in the figure here, there is a person standing. So when he look up at the upper, it is the eye of the observer. So, it is not literally when you stand there, may angle of elevation na pag tumingin ka sa taas, may angle of elevation na talaga siya. Kasi, pag tumayo ka, both my angle of elevation and depression. Like for example, I stand here, so there is angle of elevation and there is a angle of depression. So that is. So the second is, what is angle of depression? So the angle of depression is the angle between the horizontal line and the observation of the object from the horizontal line. So it is basically used to get the distance of the two objects where the angles and object distance from the around are known to us. So as you can see here in the figure, in the picture, so we can see here a person standing in the tumayo siya sa poste. So, pag tumingin siya sa baba, there is an angle of depression, but as what I said earlier na not literally na, for example, dapat umakyat ka sa punong kahoy para may angle of depression. It is not that literally means. So, pag saan ka tumatayo, there is both the angle of elevation and the depression. So, for better understanding, I will explain you deeper. What is the angle of elevation and depression? So, what is angle of elevation? So, the term angle of elevation denotes the angle from the horizontal upward to an object. So, an observer's line of the sight would be above the horizontal. So, the term angle of depression denotes the angle from the horizontal downward. So, to an object, an observer's line of the sight would be below the horizontal. It is additional information about the angle of elevation and depression. And what about the angle of depression? So the angle of depression is for when the observer is higher than the object he or she is looking at. So, when an observer looks at an object that is situated at the distance lower than the observer, an angle is formed below the horizontal line. Draw with the level of the eye of the observer and line joining object with the observer's eyes. So, whereas the angle of elevation is the angle formed if the first person stands on the ground and looks on the object kept above the ground. So, as what I said earlier, when you look at the above, there is an angle of elevation. And when you look at downward, it is an angle of depression. Or when you stand kung saan ka tumayo, there is both an angle of elevation and depression. Hindi mo kailangan umakyat ng puno para lang may angle of depression. So, I will give you an example. So please listen so that you can learn from it. So, for our example 1, we have here a ramp for unloading. A moving truck has an angle of elevation of 30 degrees. So, if the top of the ramp 0.9 meter above the ground level, then find the length of the ramp. So, since we are going to find the length of the ramp, so here is the figure. So, as we can see here in the picture, so the angle AC is the hypotenuse side, and the angle or the side AB is the opposite side, which measures 0.9 meters, and the adjacent side is the side BC. So since we are going to find the length of the ramp, so the formula we are going to use is that sine theta equals to opposite all over the hypotenuse side. Okay, for the solution, we have here. So, this is the formula we are going to use. The sine theta equals to opposite all over the hypotenuse side. So, what is the value of our sine theta? So, as we can see here, the value of our sine theta is 30 degrees. So, sine 30 degrees equals to AB, which measures 0.9 meters, and AC, which is the unknown. So, when we type the sine 30 degrees in the scientific calculator, the result would be 1/2. So, the value of our side AB is 0.9 all over the AC. So, the next step we are going to use is the cross multiplication. So, as we cross multiply this equation, so 1 times AC is 1 AC, or the 1 is cannot be seen because, or it is understandable that the value that AC has a 1 value, and then equals to 0.9 times 2. So 0.9 times 2, the result would be 1.8 meters. So the value of our side AC, or the length of our ramp for unloading the truck, is 1.8 meters. So therefore, the length of the ramp is 1.8 meters. So let's proceed to our second example. I hope you understand the way I explained. For the second example, we have here the problem. From the top of the tower, 30-meter height, a man is observing the base of a tree at an angle of depression measuring 30 degrees. So find the distance between the tree and the tower. So we're asked to find the distance between the tree and the tower. So here is our figure or the picture. So the AB here represents the height of the tower, which measures 30 meters, and then the BC here, or the side BC, represents the distance between the foot of the tower and the foot of the tree. So for the solution, here, so since we are going to find the distance between the tree and the tower, so the formula we are going to use is tan theta equals to opposite side all over the adjacent. So the value of our tan theta here is 30 degrees also. So 30 degrees tan 30 degrees or tangent 30 degrees equals to AB all over the BC. So when we type the tan 30 degrees in the scientific calculator, the result would be 1 all over square root of 3. So equals, the value of our AB is 30 meters all over the BC, which is the unknown. So, same step, cross multiplication. So cross multiplication, and the answer would be BC equal to 30. So as you can see here, 30 square root of 3. So we need to find the approximate value of the square root of 3. So as we type the square root of 3 in the scientific calculator, the approximate value is 1.732. So BC equals to 30 times 1.732, and then the value of the BC or the side BC is equals to 51.96 meter. So therefore, the distance between the tree and the tower is 51.96 meter. So let's proceed to the third example. Third example here, the problem is a man wants to determine the height of a lighthouse. So he measured the angle at A and found that tangent A is equal to 3/4. So what is the height of the lighthouse if A is 40 meters from the base? So we are asked to find the height of the lighthouse if A is 40 meters from the base. So this is our figure. For our figure, we have here the BC or side BC represents the height of the lighthouse. So which measures 40 meters. So and the BC represents the light of the house. So as we can see here, which measure, and the side AB represents the distance between the lighthouse from the point of the observation. So the side BC or the AB measures 40 meters. So now let's find the solution or the value of what is being asked. So now we need to find the height of the lighthouse or the side BC. So we are going to use the formula, which is the tangent A equals to opposite side all over the adjacent side. So for us to find the height of the lighthouse or the BC, so tangent A is equal to BC all over AB. So the value of our tangent A here is 3/4. So 3/4 equals to BC all over 40. So we are going to replace or give the value of the known value. So multiply each side by 40. So as we multiply each side by 40, so the answer is 30 equals to BC, or the value of the BC is 30 meter. So the unit is meter. So the height of the lighthouse is 30 meters. So that is the height of our lighthouse, or the side BC. Now let's proceed to our fourth example. A ladder is leaning against a vertical wall, makes an angle of 20 degrees. So with the ground, the foot of the ladder is 3 meters from the wall. So find the length of the ladder. So we are asked to find the length of the ladder. So here is our figure. So as we can see here, so AB, the AB represents the height of the wall, and the BC represents the distance of the wall from the foot of the ladder. So for the solution, so now we need to find the length of the ladder, or the side AC. So since we are going to find the length of the ladder, so we are going to use the formula cosine theta is equal to adjacent side all over the hypotenuse side. So we're going to put the known value. So cos theta equals to BC all over the AC. So the value of our cosine theta is 20 degrees. So 20 degrees equals to the value of our side BC is 3 all over the AC, which is the unknown. We are going to find the side AC. So as we type the cosine 20 degrees in the scientific calculator, the result would be 0.9397 is equal to 3 all over AC. So next step is we are going to apply the cross multiplication. So when we done applying the cross multiplication, so the answer would be AC is equal to 3.192. So this is the final result. So the length of the ladder is 3.193 and the unit is meter. So this is our final result. Now let's proceed to our last example. So the length of a string between a kite and a point of the ground is 90 meters. If the string makes an angle theta with the ground level such that tangent theta equals to 15 all over 8, how high will the kite be? So in this problem, we are asked to find the height of the kite. So here is our figure. So the figure, so here AB, our AB represents the height of the balloon from the ground. So in the right triangle ABC, the right triangle ABC or ABC, the side which opposite to angle theta is known as the opposite side or our side AB. So the side which opposite to 90 degree is called the hypotenuse side or the side AC. So and remaining side is called the adjacent side. So for the solution we have here. So we need to find the length of this side AB. So for us to find the length of the side AB, we are going to use the formula, which is the tangent theta equals to the value of our tangent theta. So 15 tangent theta equals to 15 all over 8, and the cotangent theta is equal to 8 all over 15. So in this problem, we are going to use many formulas. So the cosecant theta is equal to square root of quantity 1 plus cotangent squared theta and the quantity. So the cosecant theta equals to square root of the quantity of 1 plus 64 all over 225. So we find this 64 all over 225 because we type the cotangent squared theta in the scientific calculator. So the result would be 64 all over 225. So cosecant theta is equals to square root of 225 plus 64 all over 225. So divide, we are applying the division, and then cosecant theta is equals to 225 plus 64 is square root of 289 all over 225. So the cosecant theta is equals to 17 all over 15 rather. So that is the value of our cosecant theta, and the sine theta is 15 all over 17. So we are exchanging the numerator and the denominator. So but sine theta, so there's more. So but sine theta is equal to opposite side all over the hypotenuse side. So we are going to apply this formula or the AB all over AC. So AB all over AC is equals to 15 all over 17. So AB, so the value of our side AC is 90 is equal to 15 all over 17. So our final result for here is AB is equal to 79.41. So the height of the tower is 79.41. So the unit we are going to use is meter. So did you get what I have explained? So now it's your turn. Now I have prepared here four questions for you to be answered. So each question equivalent of 10 points. So I will read to you the questions for your activity number 1. The angle of elevation of the top of the building at a distance of 50 meters from its foot on a horizontal plane is found to be 60 degrees. So you are asked to find the height of the building. So for the second activity, for the number 2, a kite is flying at a height of 65 meters attached to the string. If the inclination of the string with the ground is 31 degrees, so find the length of the string. So you are asked to find the length of the string. So you are going to find the formula that matches what is being asked. And for number 3, you have a balloon is connected to a meteorological station by cable of length 200 meters, inclined at 60 degrees. So angle with the ground. So find the height of the balloon from the ground. So imagine that there is no slack in the cable. And for the last question, we have here a string of kite is 100 meters long and the inclination of the string with the ground is 60 degrees. So find the height of the kite assuming that there is no slack in the string. So this will serve as your assignments, and I want you to answer this with a complete solution because each number is equivalent to 10 points, and I will add 10 points to those who will submit it early. And for the next meeting, I will ask at least three participants or 2% their works in the class. So I hope you understand what I explained a while ago. So that's all for today's lecture. Enjoy and God bless. So thank you again and God bless.